This is an Internet of Things Raspberry Pi. It's power over Ethernet, meaning I can plug in my Ethernet cable, connect this to USB or micro HDMI or custom sensors, and really start doing some wacky Internet of Things. But I've been thinking, for almost as long as Level 1 has existed, I wanted to do a video like this kinda, but also have a project. And I don't really know how well this will go, but it turns out that any technology is interesting if you go deep enough. And believe it or not, we all share technology and use technologies in ways without even really thinking of it as technology. Plumbing in your house or your apartment. Electrical in your house or your apartment. The climate control system in your house or your apartment. I kind of did a video on the Iron Fireman a while back. It was an automatic coal loader. It's just a robot on it with a shovel, and it's like, this is basically the equivalent of a robot with a shovel that's going to shovel coal into your boiler, and that is, it's not Internet of Things, but it's an automaton of sorts, because you don't have to load coal in your boiler, and it'll keep your house temperate. And if you go all the way back to like the Roman aqueducts, these are technologies designed to, say, increase creature comforts. The picture on the screen behind me, that's a Samsung Smart TV. That's an Internet of Things TV. Oh wait, no, it's not a TV, it's a fridge. It's an Internet of Things fridge with a TV? This is a crime against humanity. I'm going to keep referring back to the Internet of Things fridge. The Internet of Things fridge is a dumpster fire. It is terrible. If little coal pellets were still readily available, theoretically one could actually use the coal-fired boiler. But, that doesn't make sense. Natural gas is a much better fuel, and now solar is a much better fuel on top of that, and you get some backward compatibility. But you start thinking about your house or your apartment, and you start thinking in terms of a remodel, and there's actually a lot of useful Internet of Things type functions, but it's more in a commercial setting. All of the stuff for your home is designed to rip you off. Nest, that TV, or the fridge that I'm going to continue to call a TV because it's more TV than fridge. Why? Why? You don't need a TV in a fridge. Trust me. When I was in college, I hooked a barcode scanner up to my microwave and my fridge, so I would take out a frozen dinner out of my dorm room fridge, boop, and then it would set the time on the microwave. I didn't even have to think about it. It was great. I could keep things in my brain without unloading them, and the thing would just work, and it would perfectly cook the meal according to whatever thing I had programmed for that particular barcode. It was great. Didn't have to think about it. Not having to think about it is the promise of Internet of Things devices. But what you're actually doing is creating an overly complicated Rube Goldberg machine where things never really work correctly. Do you really think in 5 or 7 or 10 years that Internet of Things fridge is going to work correctly? No, it is absolutely not going to do it. It's just not going to work correctly. So I talked about plumbing technology. Plumbing technology is interesting. Poop runs downhill, but there's actually a lot more to it than that. There's all kinds of different fittings for like how plumbing goes together. So if you're thinking about remodeling, you really need to hire a professional to at least get you oriented and pointed the right way in order to do your plumbing work. It's just plastic PVC pipes, right? And it all just runs downhill? Well, kinda, but there's actually hundreds of years of reckoning that goes into that. Those are trade skills, and you can read some books and understand and gain some experience and do the apprenticeship thing and figure stuff out. Like, I'll give you for instance, my house has a sanitary tee, and or sand tee, and is installed in a horizontal position. They're not supposed to be installed in a horizontal position. They're supposed to be installed on the waste stack, and therefore, you've got this sort of vertical PVC pipe in your house, and the toilet arm is meant to go into that. And so, like, you would use a sanitary tee there. It's got kind of like not a super steep angle of like how it transitions from a horizontal poop waistline to a vertical poop waistline, but it's not a super shallow sweep either. So if you want to do it properly, well, that's how it's supposed to be installed. If it's on its back or on its side, it's like a horizontal to horizontal transition, the curve is too steep, and so poop is likely to get stuck there. So you want to use a long sweep 90 in that configuration. Yes, I mean, both of them have the poop go at a 90-degree angle, but one of them is going to clog up a whole lot less than the other one. The other thing is, like, how much, what angle is your PVC going to go at? Well, in the US, it's about 1/4 of an inch per foot, but there's a range. If you do it too much, the water will outrun the poop and toilet paper and crap like that, and then it'll be left behind in the pipe. That's not a good situation. If it's not enough, then you'll have stuff hanging around the pipe, and that's not really a good situation either. There's also sewer gases. How do you prevent sewer gases from getting, coming back and getting into your house? Or when you flush your toilet, does it gurgle? And the reason it's gurgling is because air can't enter the system. You don't want vacuums in your PVC lines or your plumbing lines. Really old houses have cast iron, and so cast iron might mate with PVC. Newer houses have ABS instead of PVC, and you can't really mix ABS and PVC. And you can, but you got to jump through some hoops to get things to mix properly. And then there's the different kinds of cement. There's the default kind of cement for gluing PVC pipes together, sets up in about 1 second. So that's not a lot of fun to try to work on as a novice, because it's like, okay, I'm gonna glue my fittings and slide it all together. Is this gonna be a good fit? Oh, everything is set in place. Whoops, now I can't, there's just nothing you can do. You mix primer, it's like you can glue it without primer, but you're supposed to have primer on there, and the primer is the purple stuff, but not every plumber uses the purple. See, technology is interesting, no matter how deep you go. So you install an electrical panel in your house. And in the electrical panel in your house, you got neutral and ground. Neutral and ground are connected together in your main breaker box, at least in a modern main breaker box. You have gauges of wire, which are very specifically set, and you also have standards, like the insulation on the wire is tolerant up to 95 degrees C. You have 14 gauge, 12 gauge, 14 gauge for your 15 amp circuits, 12 gauge for your 20 amp circuits. Of course, if you're in the UK or somewhere else like that, there's a sort of a different set of standards. But where ground and neutral are connected together in the main panel, if you have a sub panel, ground and neutral are not connected together. And the reason for that is if you have a ground fault in the panel itself or somewhere else, you need to know that you're hitting ground and not neutral, not in the sub panel, but actually in the main panel of the house. So you see, things get really interesting the deeper you go. Suppose you've got a building like this one. It's a brick building. It's a double brick wall. It's not brick or brick veneer with cinder block behind it, which is how they did it when they realized that, wow, it's costing a lot of money for brick. We should not make the brick wall actually fully thick. And now in modern houses, they use little thin brick slices that are basically glued to wood to make it look like brick, so it's not really exactly the same. Brick is awesome. Brick weathers really well. But here's an interesting thing. If you have a house that is built with brick and cinder block or brick and brick construction, the insulation value on those walls really isn't super great. There's a bunch of companies that make a product that you can inject into the wall to give you better insulation in the wall so that your house will retain heat. The problem with that then, though, is that your exterior wall, which is brick, is going to soak up a lot more moisture. You see, it just so happens that when energy costs were super low and you had a house that had a double brick wall, usually double brick wall, sometimes they would plaster directly on the brick, but most of the time they would fur it out a little bit with wood, so you'd have a little bit of an air cavity behind the brick wall. And depending on how the wall ages, you might have moisture that migrates through the wall and then back out of the wall, but you get that air cavity so that there's some air circulation, behind the finished side of the wall, and you don't get things like water inside your house, which is always a bad thing. But if you super insulate that little cavity with products where they drill a hole and fill it with something, then you get in a situation where in winter your brick wall will freeze because there's not enough heat leaking out of your house to keep the wall above freezing. And so because of that, the bricks will age more rapidly. And if you have bricks that are a structural component, like an archway over a window, you don't have window lintels or some kind of support over your windows or something like that, then you get into a situation where after a few winters of sealing your house like that, those structural features of the brick start to collapse because of freeze and thaw cycles, because the house is retaining a lot of heat because it's better insulated. So mixing technologies in construction, it gets super interesting and super deep. So Adding a Raspberry Pi to an old house, you have to sort of be aware of all of the things, and there's not really like one compendium of putting all of that stuff together. It is a really sort of interesting situation, but and then maybe it's like, okay, I'm going to seal the outside of my brick house with a product that's like a clear sealer that will keep moisture out. Well, to a point, yeah, that'll help, but that will wear, and if it's transparent, you can't really necessarily see where it is, and then some other things happen. Modern material science on modern houses is all about moisture barrier and controlling air. You don't want any air exchange between the inside and the outside. But then the very most modern standard on the commercial side is CO2 and particulate level. So this is a very, very long-winded way of getting to what I wanted to talk about, which is CO2 level. So most modern commercial buildings monitor the CO2 level, and it's set for about 1,000 to 1,200 ppm. And most building HVAC systems will actually bring in fresh air when the CO2 level exceeds about 1,200 parts per million. Well, and the atmospheric content is about 400, give or take, 380 to 420, depending on where you are. And the more metropolitan areas have more carbon dioxide, obviously, because people are sorted together. That's a whole other conversation. Environmentalists, and then like the atmospheric average over 400, first time in human history. Let's not talk about that. So, a CO2 meter. Most residential systems actually do have fresh air intake options, or you can hook up a tube or a hose or PVC pipe or something that will allow fresh air to come in to the systems. Funny enough, systems in the 70s and 80s required it. So these new fancy refrigeration systems with the ozone-killing CFCs, yes, there would usually be a 3 or 4 or 6-inch pipe on the roof, and that was always bringing in fresh air for the refrigeration system. Most other sealed systems do away with that in the name of energy efficiency, at least in the residential systems. But in commercial systems, they're held to a little bit higher standard, so you got to have it in commercial systems. But residential systems, by and large, don't have it. Your forced air system, you can go look at your furnace. Your typical heat pump system, it does not have a fresh air intake. They figure that your house is leaky enough, the windows and around the doors and stuff like that, you're going to be getting fresh air. But working from home, the CO2 level, it'll be higher than you expect. So there's a data logging CO2 monitor. This is the one that I ordered from Amazon. It's portable, it's standalone, it's great, it works fine. For a house remodel, I'm installing LG mini split cartridge system. So each major room basically gets its own mini split HVAC. The LG system has an optional fresh air intake. I don't know that I want the fresh air intake to be open all the time. I kind of want to be able to monitor the CO2 level in the room, log it, send it back to something like a Raspberry Pi, and then have the Raspberry Pi open up the ductwork that will allow fresh air to come from the outside. Now, if there's a gas leak or some other environmental concern, maybe I don't want to do that. Maybe I don't want to bring in fresh air from the outside. Other things like radon. Maybe I want to be able to monitor radon and carbon monoxide. Of course, there are standard devices for monitoring that, but it would be nice if you could tie it in a standard kind of way. The good news is that there are standards that are coming about that will let you tie these devices together, and it's not Captain Smart Fridge over there, because that is a dumpster fire of insanity. But the protocols so far don't have a good track record for security. So I've got some electrical outlets and some carbon monoxide detectors that are Z-Wave compatible. Lowe's sells Z-Wave smoke detectors and carbon monoxide detectors and combo devices. There are a couple of Z-Wave carbon dioxide detectors, the concentration, but you're going to be better off using the one that I got with the serial logger data output and a couple of USB adapters with your Raspberry Pi. But being able to monitor that in your working environment, in your home, that's the value add. That's going to add better comfort and be more useful to you than Smart Fridge. So I was thinking about putting together a series of videos where it's like, okay, if we want to do the Internet of Things, maybe we should do the Internet of Things correctly. And what sorts of things will be useful for Internet of Things? Well, I would like to be able to monitor energy usage. A heat pump energy usage, that can be an early warning sign that you're low on refrigerant, or that there's a malfunction, or that it needs to be hosed out because you get debris in the coils in the outside heat pump unit. And when that happens, it can't dissipate heat as effectively, and you need to go hose it out. Maybe that's something you do every year. Maybe something, your neighbor had a trash fire while you were at work and you didn't know. And it's like, that's weird. The heat pump is mysteriously more dirty than it usually is. Oh, it was because of all the particulate matter from the other thing. You can also do particulate matter monitoring inside your house, because that also affects the old cognitive function and how all that works. So in terms of like what I would find useful in a residential scenario in terms of Internet of Things devices are things like water usage, energy usage, CO2 concentration, things like carbon monoxide, and all the safety stuff, carbon monoxide, radon, if you're in an area that has radon, those kinds of things. And chart it and keep track of the data. A nice Grafana graph of all of that information. We have the technology to build that, and we can interface with third-party things that are kind of okay Internet of Things like Z-Wave and Zigbee and some of the other stuff. You can do home automation with some of these utilities, but I always want to do this type of automation in a way that you don't really lose anything. Everything is still operational, assuming all of the other stuff doesn't work correctly. So maybe there's a control panel in the basement where I can manually control, which mini split systems are receiving fresh air from the outside. But I can also see on the control panel what the readings are for the CO2 and what the Raspberry Pi software is requesting for, opening or closing those external vents. Because, on a day that's 115 degrees outside and your internal CO2 level is like, 450, you really don't want to bring in that super hot air from the outside. That's just going to be harder on your central air system and generally not a good thing. And you don't really have to have new home construction to have all of these wonderful features. Even just basic things like running Cat 6 everywhere. Yes, Cat 6, not Cat 5 or Cat 5e, because Cat 6 has better lightning immunity. Just all those little details. It's like the Santee versus the Y, or the Y with the 1/8 combo. It's like you don't know that until you need to know that, until it was already too late. And then somebody's like, oh yeah, by the way, you need to know this thing. Or the ground neutral bar. It's like, well, on a sub panel, you don't actually connect ground to neutral because you want ground to go all the way back to the main panel, not connect to neutral in the sub panel, because you wouldn't know if you had a ground fault. So it's really interesting the deeper you go. So I'm thinking about a new video series, if this is something you want to see, more stuff like the Iron Fireman, but also like, hey, let's make some Internet of Things that are useful. It could be a whole bunch of videos, maybe not. It's a little unusual for this channel. Maybe I could put some of it over in the Linux channel, because a lot of it is going to be Linux powered. It's like, my home runs Linux because it's the quarantine, and what else am I going to do? Two projects I'll give a quick mention to. HomeAssistant.io. It looks like there's a version of this for the Raspberry Pi. It's like Has.io that includes Docker to make installing a lot of this stuff easy. Now, it does have integration with other smart home assistants like Alexa and Google, but I'm not super interested in that. An honorable mention from Mycroft. It's like home-based, offline, doesn't need to be connected to the cloud voice assistant. Both of these projects have the same philosophy, which is, the smart home shouldn't be absolutely just destroyed and offline if your house is unplugged from the internet. But more importantly, it's the ideals of the smart home is that the smartness basically gets out of the way. I want to do things like monitor the airflow through the HVAC system, and it's like, oh, the airflow is down for some reason. I bet the filters are dirty. Maybe I should reorder filters on Amazon. Yes, that's actually useful. Maybe I get a pop-up on my phone. It's like, hey, is it okay if I reorder filters? Airflow is down today. Yes, that sounds good. Maybe the smart toilet that analyzes your poop could be tied in as well. I don't know. We're not going to do a video on that. We might do a video on that if they send me one. I mean, they could. And stranger things have happened. All right, that's enough rambling for now. I wonder if this is level 1. It's like This Old House Linux edition. I don't know. I kind of don't want to do that but I kind of do, but only if it's something that will be super interesting. And also, I really like watching Paul's Hardware remodel his kitchen, and it's a lot of fun and exciting. And I can sort of live vicariously through all the fun and exciting things that he's doing. The difference is that all the technology that goes into the creature comforts of your house. I find all of that super, because it's diagnostics. It's like, I want to run the level 1 diagnostics on why is this the way that it is. But there you go. I'm Wendell, this is level 1. I'm signing out, and I'll see you later. Remember, this is a crime against humanity. This fridge, it's terrible. Why would you do that? Why would you have that kind of a fridge and not a CO2 detector? That's crazy.